Have you ever wondered why the northern lights happen whenever the sun has solar flares? No, it's not random magic, and neither is the sun a spiteful being. It's part of a cosmic chain reaction that started at the sun and ends here on Earth. And the force responsible for all of this is called MHD Flow. MHD stands for Magneto-Hydrodynamics. And yes, that is a real word, not some made up jargon. But don't worry, today we're breaking down what it means. First of all, let's dissect what magneto-hydrodynamics actually means. Magneto. This means magnetic fields, like the ones around the Earth or the Sun. One important thing to note is that magnetic fields can act upon moving charges inside a conductive fluid. Hydro. This means fluids, and in this case, the fluid we are talking about is called plasma. Dynamics. This is just another word for movement. So, MHD flow is a study of how electrically charged fluids move when magnetic fields are involved. Still confused? I don't blame you. Let's explore magnetic fields and plasma in more detail. Okay, but what is plasma? Plasma is basically a gas that's so unbelievably hot that the atoms break apart. And yes, there are more than 3 states of matter. The negatively charged electrons get knocked loose, leaving behind positively charged particles called ions. So instead of a usual gas, you get a kind of soup of positive ions and negative electrons flying around. Because these particles have an electric charge, plasma can conduct electricity, kind of like wires in your phone or computer. Plasma is the most common form of matter in the universe. Stars, lightning, even neon signs are all made from plasma. Magnetic fields. Magnetic fields are invisible lines of force that change the movements of charged particles. Imagine rubber bands stretched across space. They pull on charged particles, guiding their movement in particular directions. If you've played with magnets, you know how they can attract or repel metal objects. Magnetic fields do exactly the same, but they act upon these charged particles. The pushing and pulling of these particles cause movement. How do plasma and magnetic fields interact? This is where it gets interesting. Because plasma is charged, it responds to magnetic fields. But plasma doesn't just get knocked around, the interaction goes both ways. Magnetic fields push and shape the plasma. The plasma can tug back, dragging and warping the magnetic field lines with it. Kind of like stirring a very volatile bowl of spaghetti. As the plasma moves, it stretches and twists the magnetic lines. This isn't as notable on its own, but in large masses like the sun, when the stress becomes too much, the field lines can suddenly reconnect, snapping into a new shape. This rapid change unleashes a burst of energy, sending charged particles to blast out into space. This is what happens during solar flares or coronal mass ejections, like those massive space explosions from the sun. And this process is called MHD flow. While this is fascinating and all, you might be wondering, why should we care? Because MHD flow affects us here on Earth. When the sun sends out these bursts of plasma and magnetic energy, they slam straight into Earth's magnetic field. Charged particles spiral at incredible speeds along magnetic lines and collide with the atmosphere, lighting the sky in beautiful, colourful waves, known as the northern and southern lights. However, it doesn't stop there. These space storms can cause potentially catastrophic problems with the technology that humans rely on. To start with, they mess with satellites. Believe it or not, but space can induce power lines on Earth, even though these storms are happening in space. In 1989, a solar storm actually knocked out the entire power grid in Quebec, Canada. And just like that, millions of people still in the dark because the sun sneezed. So, to summarize, MHD flow is the interactions between super hot charged plasma and invisible magnetic forces. It explains the sun's passive aggressiveness, the beautiful auroras and space weather that affects our tech. The next time you see those shimmering lights in the sky, remember, it's not magic. It's angry plasma soup and snapping magnetic rubber bands all playing out millions of miles away. Thank you for watching this episode of Astrophysics Explained for Non-Nerds. If you enjoyed it, hit subscribe. If you have any suggestions for what astrophysical concepts to tackle next, leave a comment down below.